We live in a universe of patterns. Every night, the stars move in circle across the sky. The seasons cycle at yearly intervals. No two snowflakes are ever exactly the same. Tigers and zebras are covered in patterns of stripes. Leopards and hyenas are covered in patterns of spots. Intricate trains of waves march across the oceans. Very similar trains of sand dunes march across the desert. Let's dive deeper into the world of mathematics through Ian Stewart's book, Nature's Number. But before we formally start our discussion, let us introduce ourselves first. I am Johara M. Gindo.
I am Mylene O. Malimata.
And I am Karen O. Makarang.
We are the Group 1, the assigned reporters in Chapter 1, The Natural Order.
What is natural order? The orderly system comprising the physical universe and functioning according to natural as distinguished from human or supernatural laws. Ian Stewart begins the book by describing just some of nature's multitude of patterns. So, what is mathematics? Mathematics is the act or process of performing mathematical operation to find a value. Next is, what is mathematics? Because of mathematics, we discover a great secret that using mathematics to organize and systematic our ideas about patterns.
Johannes Kepler, a German astronomer. He is born on December 25, 1571 in Wilderstadt, Germany, and he died November 15, 1630 in Regensburg, Germany. His contributions: 6 concentric snowflakes, theory of the existence of precisely 6 planets, orbital period of the natural order of planets. It is a small book as a New Year's gift to his sponsor. Snowflakes must be made by packing tiny identical units together. Kepler performed no experiments. He just thought very hard about various bits and pieces of common knowledge. He devised a simple and tidy theory for the existence of precisely 6 planets, and those are Mercury, Venus, Earth, Mars, Jupiter, and Saturn. Kepler found that if you take the cube of the distance of any planet from the Sun and divide it by the square of its orbital period, you always get the same number.
Two types of pattern. First is the fractals. These are geometric shapes that repeat their structure on ever finer scales. The examples of these are branches of trees, animals, circulatory systems, and snowflakes. The second is the chaos. This is a kind of apparent randomness whose origins are entirely deterministic. The examples of this are cloud patterns and the currents of the ocean. Simplest. The simplest mathematical objects are numbers, and the simplest of nature's patterns are numerical. Example: the phases of the moon make a complete cycle from new moon to full moon and back again every 28 days. In nearly all flowers, the numbers of petals is one of the numbers that occur in the strange sequence 3, 5, 8, 13, 21, 34, 55, 89. There is a definite pattern to those numbers, but one that takes a little digging out. Each number is obtained by adding the previous 2 numbers together. Example: 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21, and so on.
Numerology. is the easiest and consequently the most dangerous method for finding patterns. It is easy because anybody can do it and dangerous for the same reason. The big problem with numerological pattern seeking is that it generates millions of accidental for each universal. Isaac Newton, born January 4, 1643 at Woolsford Manor House, United Kingdom. Died on March 31, 1727 at London, United Kingdom. Contribution: Theory and gravity explain all sorts of puzzles about the motion of stars and planets. In contrast, Kepler's neat, tidy theory for the number of planets had been buried without trace. For a start, it must be wrong because we now know of 9 planets, not 6 planets. Isaac Newton, he is mathematician, physician, astronomer, and an author.
2 mathematical patterns. Numerical pattern. A numerical pattern is a sequence of numbers that has been created based on a rule called a pattern rule. Pattern rules can use one or more mathematical operations to describe the relationship between consecutive numbers in the sequence. A geometric pattern is a kind of pattern formed of geometric shapes and typically repeated like a wallpaper design.
Benoit Mandelbrot, a French and American mathematician. He was born on November 20, 1924 in Warsaw, Poland, and died on October 14, 2010 in Cambridge, Massachusetts, in United States. He introduced fractals. He concluded that real roughness is often fractal and can be measured. Although Mandelbrot coined the term fractal, some of the mathematical objects he presented in the fractal geometry of nature had been previously described by other mathematicians. We enjoy reading Ian Stewart's book because it is truly interesting, informative, and educational in a way that he presented and provided evident examples of mathematics in our nature, and he writes with clarity and precision. We don't pay attention to those patterns, but because we've read the book, we realize that it really exists and we just ignore them. We have also learned that patterns of form and motion reveal deep regularities in the world around us, specifically the six-fold snowflakes, which led Kepler to conjecture that all matter is composed of atoms. Patterns of waves and dunes give clues to laws of fluid flow, and tiger stripes and hyena spots give a key to understanding the processes of biological growth. This ends our report about the natural order of Ian Stewart book's Nature's Number.
Thank you guys for watching and listening. Bye-bye!